Example number 3. In this example, we're actually going to be determining the area under the region of the graph of f on this closed interval a, b. So we're basically going to handle it the same way, but we are actually determining area now because this entire graph is located above the x-axis. So that's why we're able to call it area and not just the value of the definite integral. Because everything that will be shaded here would be representative of positive y values. So anywho, what we're going to do is this. Area now is going to be equal to what? Well, you're just going to use this information and set up a definite integral. So here is your setup. All right, so there's your setup. And so this is different than what we've seen thus far looking at definite integrals, I believe, because there's no way you can make a substitution here and come up with a constant 2. With that being said, one of our properties allows us to do this. One of our properties allows us to rewrite this single definite integral as the sum of 2 distinct definite integrals. So that's going to be the key here, understanding that property and being able to apply it. Rewriting one integral as the sum of 2 distinct integrals. At this point, we need to recognize that we're good here. I mean, the integral of 2 with respect to x is going to be 2x. So the actual value of this integral is just going to be 2 times 3, 6, and that's going to be the result, 6. This is the one we have to be concerned about in terms of u substitution. So let's work on that now. Let's go ahead and I'll show that work over here. Let's let u be equal to what? Let's let u be equal to this x plus 1. And now let's take the derivative of each side. So on the right side of this, when we derive it, we just get 1 dx or just dx. So again, what's happening? Well, we're able to match things up, I think. We have the x plus 1 taken care of, and then we have the dx taken care of. The only thing that's not taken care of is this, this radical component, right? All right, so let's rewrite this. Let's change our limits of integration. So initially, what do we have? Well, upper limit was 3, so plug in a 3 for this x. And you get 3 plus 1, which is 4. And then down here, change our lower limit of integration. 0 plus 1 is 1. And now let's rewrite it in terms of u. So u is equal to x plus 1. There's x plus 1. So this is u to the 1/2, right? The square root of u is the same as u to the 1/2. And that's going to be with respect to du. So there's our new integral in terms of u. So let's rewrite it and let's evaluate it. All right, so area is going to be what? Let's go ahead and just keep this the same for now, even though we know what the answer is going to be, I hope. Oops, don't forget your 2. So again, this is going to give us a 6. I'm going to show you the work here. So I'm going to rewrite this integral, which was originally in terms of x, now in terms of u, right here. Okay, so what do we get? The value of this definite integral, all right? What's the integral of 2? With respect to x, it's 2x. Okay? All right. And now, what about this one? We're going to add what? Well, the integral of u to the 1/2 is u to the 3/2. And then we're going to really be dividing by 3/2. But again, folks, when you divide by 3/2, it's the same as multiplying by 2/3. And we're going to look at evaluating this from our lower limit of 1, not 0, 1 to 4. Okay, so what do we get? This is going to result in 2 times 3 minus 2 times 0, which is 6 minus 0, or 6. So right here gives us a 6. And then the next part is going to be what? I'm going to go ahead and factor out the 2/3 and just rewrite this as 2/3 times what? Upper limit goes first, 4 to the 3/2, and then minus your lower limit, which is 1 to the 3/2. So what do we get here? Let's see. We get 6 plus 2/3 times, 4 to the 3/2 is 8. 1 to anything is, what? 1, yes, good. All right, so this is gonna give us 7. 7 times 2/3 is 14/3. So what is 6 plus 14/3 in other words? What's 6 plus 14/3? I don't know. 6 plus 14/3. Hit math, enter, enter. Always express your answer in fractional form unless you were told otherwise. So 32/3. And because this is area, it is units squared. Finished with example number 3.